we know that we often refer to technological objects or, machines as systems, because a system is a group of subsystems, which are clusters or smaller groupings of components, also known as parts, that accomplish different tasks in a machine. Your textbook on page 389 breaks down the bicycle as a system, and it talks about how all of the different parts on a bicycle are actually part of different groupings that accomplish certain tasks. So I'm going to actually use the human body as an example. The actual iBook talks about the bicycle as an example, but I think in order to understand this a little bit more, I think you're going to be able to relate a little bit better to the body and the systems of the body. The human body is pretty much the most complex system out there in terms of living organisms that we know of. Okay, and that's true of all mammals. Now, if we look at this image where it says body systems, I'm actually going to change this up a little, and I'm going to actually write body subsystems, because that's what each of these different chunks of human organs are. Okay, they're different groupings of components of the body or parts of the body that accomplish specific tasks. So the human body as a whole is the system. And every one of these little breakdowns, so here we've got the normally we combine the two, but the muscular subsystem, and it looks at all the different muscles of the human body. We've got the skeletal system. We've got the circulatory system, the nervous system, the lymphatic system, the respiratory, the endocrine system, the digestive, excretory, and reproductive. Now, these subsystems all have several organs to them or components. And these components are grouped together because to accomplish a specific task. If I look at the respiratory system here, the respiratory system involves your nose, your nasal cavity, your pharynx, which is your throat. It involves your larynx, which is your voice box, your trachea or your windpipe, and then the actual lungs themselves. Okay? And within the lungs, we've got blood vessels, and we've got these we've got these smaller branches called bronchi that break into even smaller branches called bronchioles that have tiny little sacs of air at the end of them called alveoli. All of these are components, and you don't have to know this, but what I'm trying to illustrate here is that this subsystem has a role in the human body, in the human system. It has the role of exchanging carbon dioxide and oxygen. No other parts in the whole system do that. So when we look at the bicycle on page 389 of our textbook and in our iBook, we see that we've actually broken down the different parts of the bike that accomplish certain tasks. And you'll notice that when you actually give something a name, so a subsystem, we have our system here, which is the machine itself. And when we actually break the system down into our different subsystems, we actually choose to name those based on the task they accomplish. So if we look at the bicycle, you can either follow in your iBook or follow in your textbook if you're actually listening to this video with the iBook. You'll notice I'm going to look at the frame here. The frame is the actual piping or tubes that make up the actual bicycle. And from that, we attach all these different components to the actual frame in order for the bicycle to work. So its function is to hold all the subsystems together. Oftentimes, a machine will have, or a system will have, an actual frame to it that other actual parts are attached. The other one that's quite common in a lot of actual systems is something called the transmission. Now, the transmission has as a job to take an actual energy input somewhere and transmit it to somewhere else. And if we actually look at the pedals of the bicycle, so we know that the bicycle has these pedals here, okay? And these pedals turn in a rotational fashion, and we know that we have an actual gear here, and then that there's an actual chain that attaches this to a smaller gear system, which is attached to the back wheel. So as we actually turn these pedals, it's going to turn the chain in this direction, which is linked to this back wheel and causes the back wheel of the bike to move. So what we're doing here, okay, what we're actually doing is we're transmitting an input motion to the pedals, and we're transmitting it to the back wheel to make the wheel turn. Okay, so oftentimes machines that have motion in them will have something to input the motion, and it'll transmit the motion to somewhere else. So within this actual subsystem, we've got a few parts here in the bicycle. Okay, we've got the actual pedals, we've got these gears, we've got the chain, we've got the gears at the back here, and then we've got the back wheel. So when we're talking about the different components that go into a subsystem, we have to list each component out that is part of that subsystem. And here's the thing. Components or parts can be in more than one subsystem. Sometimes there's only one part in a subsystem. Look at the actual seat of the bicycle. It's all by itself in its subsystem, but it's super important to the bicycle. Okay, in the case of the transmission, you could choose to group the back wheel in there. I noticed the textbook hasn't, because the wheels themselves are also in a subsystem of their own because they allow for motion, let's say. Okay, so you could group motion and steering together, or you could put steering by itself and motion by itself. When we actually choose the subsystems, it is kind of subjective, which means one person will choose to have or will see a system, a machine in one way, and I'll say, okay, I see these subsystems, I see these subsystems and these ones. And somebody else will come back and they'll switch it around. So on a test or on an assessment, I will tell you how many subsystems I want you to find. Okay? And you'll get used to, we're going to actually do an activity with an apple peeler to actually group different components within different subsystems.